In this video, I'll be solving the first part of the first problem of UPSC Civil Services Mains 2017 Statistics Paper 1. So 10% of a certain population suffer from a serious disease. Two independent tests are given to a person suspected of the disease. Each test give a correct diagnosis 90% of the time. So we need to find the probability that the person really suffers from the disease, given that both tests are positive and only one test is positive. So first, like if I consider D is the event where a person has a disease, so probability of D is 0.10. So probability that a person is positive, so we are given that probability, each test gives a correct diagnosis 90% of the time. So that means it will give positive given a person is having density, having a disease is 0.9. So that means probability of negative, so given there is a disease, is 0.1, and probability of getting positive given the person has no disease, so that is D complement, so that is nothing but 0.1, and probability that a person is getting negative given the person has person doesn't have the disease, so that is 0.9. So first we are asked that find the probability that the person really suffers from the disease given that both tests are positive. So that means we are asked to find probability of disease given both tests are positive. So first we can easily find like probability of both tests are positive given the person is having disease. So that is nothing but probability of getting positive in the first test, and since both the tests are independent, we can multiply into probability of positive in the second test as well. So that is nothing but 0.9 into 0.9, which is 0.81. The similar way, probability of both positive given the person doesn't have the disease, so that is like probability of positive given the person is not having the disease into probability of positive given the person is not having the disease, which is 0.1 into 0.1, which is 0.01. So now if we have to find probability of person having disease given both tests are positive, so that is nothing but by using Bayes theorem, probability of both tests are positive given the person is having disease into probability of the disease divided by probability of both tests being positive. So that is nothing but, so probability of both tests are positive given the person is having the disease, that is 0.81 into the probability of having a disease. So basically 10% of the certain population suffer from a disease, so that means probability that a person is having the disease is 0.1 divided by probability of both having disease, that is nothing but probability of both having disease given is really having the disease into probability of disease plus probability of getting both tests positive given the person is not having the disease into probability of not having the disease. So that is nothing but 0.81 into 0.1 divided by, so this is nothing but probability of both the tests are positive given the person is having the disease, that is 0.81 into probability of having a disease is 10% of the population, so 0.1 plus 0.01 into 0.9, so that is nothing but 0.081 divided by 0.081 plus 0.009, which is nothing but 81 by 90, which is 0.9. So therefore probability that a person is really having the disease, really suffering from disease given both tests are positive is 90%. Now we are asked to find probability that the person suffers from disease given that only one test is positive. So probability of, like first, like if we have to find probability of exactly one test positive, so probability of exactly one positive given the person is having disease, that is nothing but either it can be in the first test it is positive and second test it is negative, or first test it is negative and second test it is positive. So 2 into 0.9 into 0.1 will be probability of exactly one test being positive given the person is having the disease. Now given, and similarly probability of exactly one positive given the person is not having disease. So that will also be like 0.1 into 0.9 plus 0.9 into 0.1, which is 2 times 0.9 into 0.1. So therefore probability of having disease given exactly 1 positive, so that is equals to probability of exactly 1 positive into probability of given the person is having the disease into probability of having probability of deceased divided by probability of exactly 1 positive given the disease into probability of disease plus probability of exactly 1 positive given there is no disease into probability of no disease. So that is nothing but 0.18 into 0.1 divided by 0.18 into 0.1 plus, so this will be 0.18, still probability of exactly 1 positive given no disease is 0.18 into probability of not having disease, which is 0.9. So that is nothing but 0.018 by 0.018 plus 0.162, which is 0.018 by 0.180, which is 0.1. So that means if both tests are positive, the posterior probability of disease increases to 90%. In the first case, we are getting 90%. Now, if exactly one test is positive, so that means the posterior remains at the prior possibility. So the prior probability is just 10%. So we can see like the probability is remaining at 10% because a single positive is means like the disease is under like no disease. So like given the symmetry, so therefore probability that the disease given like both are positive is 90%, and probability deceased given like exactly 1 positive is 10%. So that's it for this video. We'll meet in the next video.